1,800 miles beneath your feet. Sitting directly on top of Earth's molten core, there are two objects that should not exist. Each one is roughly twice the size of the Moon. Together, they cover close to 1/10 of the entire volume of our planet's interior. They have been sitting there, unmoving, for what may be billions of years. And for most of human history, we had absolutely no idea they were there at all. We only found them by accident, decades ago, while listening to earthquakes. And the more scientists have studied them since, the stranger the story has become, because the leading explanation for what these two things actually are is not a type of rock anyone expected to find inside our own planet. It might be the leftover body of another world entirely, a world that no longer exists, because 4.5 billion years ago it hit us and never fully left. Here's the part that should stop you cold. We have sent spacecraft past every planet in the solar system. We have driven rovers across the surface of Mars. We have photographed galaxies so far away, their light left before Earth even had continents in their current shape. And yet the deepest hole human beings have ever physically dug into our own planet reaches barely 7.5 miles down. Scratch a pinprick compared to the roughly 4,000 miles separating us from the center of the Earth. We understand the outer edge of the observable universe better, in some ways, than we understand what's directly beneath our own 2 feet. Buried in that darkness we've barely touched. Scientists have found something that genuinely does not fit the story we thought we knew about how our planet formed. If stories like this are the reason you're here, hit subscribe now, because this one only gets stranger from here, and you don't want to miss where it ends up. Here's where we're going. First, we're going to talk about how anyone could possibly see something 1,800 miles underground in the first place. Scientists actually found there back in the 1980s that immediately broke the existing, back to the single most violent event in our planet's entire history, the collision that created the Moon. After that comes the twist. Because the picture scientists have built over the last 2 years is far messier and far more interesting than 2 giant blobs. New research is now revealing dozens of smaller, previously invisible structures scattered throughout the deep Earth, and an entirely separate mechanism that may be reshaping the boundary. Let's start with the obvious problem. You cannot drill to the center of the Earth. The pressure would crush any machine humans have ever built long, before it got anywhere close, and the temperature at the core exceeds the surface of the sun. So how does anyone claim to know what's sitting 1,800 miles down in a region no human instrument has ever physically touched? The answer is earthquakes. Every time a major earthquake occurs anywhere on the planet, it sends waves of seismic energy radiating outward in every direction, not just along the surface, straight through the interior of the Earth itself, passing through the crust, the mantle, the outer core, sometimes all the way to the other side of the planet. Seismologists have spent the last century building an enormous global network of sensitive instruments that can detect these waves arriving from earthquakes thousands of miles away. Because seismic waves travel at different speeds depending on the density, temperature, composition of the material they're passing through. Scientists can use the timing and behavior of those waves to reconstruct a 3-dimensional map of what's actually down there, a technique called seismic tomography, which works on roughly the same principle as a CT scan, except the patient is an entire planet. And the X-rays are earthquakes happening at random, anywhere on Earth, whenever the planet decides to produce one. In the early 1980s, using this exact method, geophysicists noticed something that didn't fit any existing model. In 2 specific regions deep in the lower mantle, one sitting beneath the African continent, one sitting beneath the Pacific Ocean, both resting directly on top of the boundary where the rocky mantle meets the molten metal of the outer core, seismic waves were behaving. Strangely, they slowed down dramatically as they passed through these regions, far more than the surrounding mantle rock would predict. Slower seismic waves generally mean denser, hotter, or chemically different material. And the regions producing this effect weren't small, they were continent-sized. Each one measured up to 1,000 kilometers tall and several times that wide, together occupying somewhere between 3 and 9% of Earth's entire volume. Scientists gave them a suitably dry, technical name, Large Low Shear Velocity Provinces, or LLSVPs for short, and then spent the next 4 decades trying to figure out what on Earth, quite literally, they actually were. Try to picture the actual geometry of what was found, because the scale is easy to say, out loud and genuinely difficult to hold in your head. If you could somehow strip away the ocean floor beneath the Pacific and the ground beneath West Africa, and keep drilling straight down for 1,800 miles past the crust, past the upper mantle, past the transition zone where rock becomes so compressed its very crystal structure changes, you would eventually arrive at two structures sitting almost like a pair of countenances pressed flat against the top of the core on opposite sides of the planet, roughly antipodal to one another. Scientists sometimes describe their arrangement as resembling a pair of headphones wrapped around Earth's molten heart. Each one taller than Mount Everest is high, many times over, if you could somehow stand it on its end. And they have almost certainly been sitting in roughly that same configuration for an extraordinarily long time, potentially since not long after Earth itself finished forming. For a long time, the leading guesses stayed relatively mundane, at least by the standards of planetary science. Maybe they were simply unusually hot regions of ordinary mantle rock, thermal anomalies with no exotic origin at all. Maybe they were slab graveyards, the accumulated remains of oceanic tectonic plates that had been sinking into the SC mantle for hundreds of millions of years through a process called subduction, piling up at the core mantle boundary like sediment settling at the bottom of a lake. Both explanations had support. Neither one fully explained everything scientists were seeing, particularly the fact that the two blobs, despite sitting on opposite sides of the planet, appeared to have distinct and different densities and compositions from one another and from the mantle surrounding them. Something was still missing. Then, in 2023, a team of researchers led by geodynamicist Qian Yuan proposed something considerably bolder, and it's the theory that's dominated the conversation ever since. To understand it, you have to go back to the most violent single event in the history of our planet, roughly 4.5 billion years ago, when Earth was still a young, half-formed world barely tens of millions of years old, a separate protoplanet roughly the size of Mars. Given the working name, Theia is believed to have slammed into it at a glancing angle, in a collision so catastrophic it nearly tore the young Earth apart. Enormous volumes of molten and vaporized rock were blasted into orbit, and over time that debris cooled, clumped together, and became the moon. This isn't speculation for shock value, it's the leading scientific model for how the moon formed. Supported by decades of lunar sample analysis and computer simulation, and it's about as close to settled science as origin stories in planetary astronomy get. But here's the question that took scientists decades to seriously confront. If an entire Mars-sized planet slammed into Earth with enough force to blow a chunk of both worlds into orbit, where did the rest of it go? Not all of they would have escaped into space to form the moon. Simulations have long suggested that most of the impactor's mass, its core, its mantle, the bulk of its material should have been absorbed directly into the young Earth. And yet, despite decades of searching meteorites, asteroids, and every corner of the solar system we've been able to examine, not one confirmed trace of the thought has ever been found anywhere except indirectly in the moon itself. Yuan's team modeled what would happen to the dense, iron-rich mantle material from an impactor like Theia after being absorbed into early Earth. Their simulations showed that this material, chemically distinct, 2 to 3.5% denser than the surrounding proto-Earth mantle, would not simply blend in evenly over time. Instead, over the following billions of years of slow, grinding mantle convection, it would gradually sink, settle, and accumulate into exactly the kind of continent-sized, chemically distinct piles resting at the core mantle boundary that scientists had already been puzzling over for 40 years. The two LLSVPs, in other words, may not be leftover pieces of Earth at all. They may be the buried, half-digested remains of an entirely separate planet, one that technically stopped existing 4.5 billion years ago, but whose body has been quietly resting inside ours ever since, wedged directly against the boundary of our planet's molten heart. Sit with that for a second, because it deserves more than a passing mention. Somewhere beneath West Africa right now, and somewhere beneath the floor of the Pacific Ocean, there may be the physical remains of a world that collided with our own before Earth had oceans, before it had a solid crust in any form we'd recognize today, before there was a single living thing anywhere on its surface. It's not myth, not metaphor, actual planetary material from an actual planet, sitting less than 2,000 miles beneath, wherever you happen to be reading this right now. Think about everything that has happened on the surface of this planet since that material settled into place. Every supercontinent that has ever formed and torn itself apart, Rodinia, Panotia, Pangaea, assembled and broke apart directly above these structures without disturbing them. Every mass extinction, including the asteroid impact that ended the age of the dinosaurs, played out entirely within a thin, fragile shell of crust, an ocean sitting on top of a much larger, much older wound that Earth sustained during its own violent infancy. Human civilization, in its entirety, every war, every empire, every book ever written, every person who has ever loved another person, or built something, or looked up at the stars and wondered what was out there, has unfolded across roughly the last 10,000 years. A sliver of time so thin against 4.5 billion years that it barely registers. Directly above two structures that may be older than the ground itself. Not every scientist is convinced, and it's important to be honest about that, because this is still very much an active, contested area of research rather than settled fact. Seismologist Jennifer Jenkins of Durham University, reviewing Yuan's work, noted that Advaya-derived origin isn't inconsistent with the data, but said she wasn't entirely convinced either, pointing out that if the LLSVPs really are remnants of the impactor, their relatively modest mass could complicate existing assumptions about how large they actually was. Other researchers have proposed that the two structures could still be a mixture of explanations layered on top of each other, part ancient impactor material, part accumulated slab graveyard, chemically blended together over billions of years of convection until the original sources become almost impossible to fully untangle. Scientists studying this have suggested one promising way to actually test the idea, comparing the chemistry of volcanic island rocks, which occasionally carry material up from near these deep structures, against lunar samples collected from the Moon's largest impact basin, samples that both NASA and China are now actively planning missions to retrieve from the lunar South Pole specifically to help answer this question. In other words, we may need to go back to the Moon to finally understand what's buried inside the Earth. That last point deserves a moment of its own because it's one of the more elegant ironies buried inside this entire story. For over half a century, the Moon has been treated as a finished chapter in planetary science, a place we've already been, already sampled, already mostly understood, its origin story settled by the Apollo missions decades ago. But if the LLSVP hypothesis holds up, then the Moon isn't a closed book at all. It's a physical alibi, a surviving witness to a crime. Scene that's still, in a sense, active 1,800 miles beneath our feet. Rock brought back from the Moon's far side, from craters deep enough to have excavated material from its own interior, could end up being the single piece of evidence that finally confirms or eliminates the idea that a second planet is quietly buried inside our own, which means the next major discovery about the deep Earth may not come from a borehole or a seismometer at all. It may come from astronauts or robots, scooping up dust on a world 250,000 miles away. And here's the twist. Because just when the two giant alien blobs story felt like the whole picture, new research over the past 2 years has made the deep Earth look considerably messier, considerably more alive than anyone expected. In 2025, researchers using an enormous global data set of seismic recordings, analyzing thousands of echoes bouncing off the core mantle boundary at once, rather than examining a handful in isolation, the way earlier studies had discovered that the LLSVPs are not the only strange structures down there. Far from it, the team working out of the University of Maryland and publishing in the journal Science identified far more widespread, irregular pockets of unusually dense, hot rock scattered across the core mantle boundary than anyone had previously mapped, including a previously unknown structure beneath the Marquesas Islands in the South Pacific, and a structure beneath Hawaii that turned out to be considerably larger than earlier estimates suggested. These smaller formations, known as ultra-low-velocity zones, behave almost like thin, molten puddles pooling directly on top of the core, distinct from the two massive LLSVPs, but sitting near their edges, and their sheer number suggests the boundary between Earth's rocky mantle and its liquid metal core is a far more chemically complicated, far more textured landscape than the simple two-blob picture ever captured. One of the researchers behind that study, Doyen Kim, described the shift in perspective plainly by examining thousands of these deep echoes together, instead of one region at a time, the way earlier seismologists were forced to. The team finally got what amounted to a wide-angle photograph of a landscape that had only ever been viewed before through a narrow keyhole. And what that wide-angle view revealed was a core mantle boundary, pockmarked with structure patches of ultradense rock scattered like scar tissue across a region of the planet that textbooks, as recently as a few years ago, still described as smooth and largely uniform. Some of these newly identified patches sit only a few 100 kilometers across, tiny compared to the two continent-sized LLSVPs, but there are far more of them than anyone previously suspected, clustered particularly near the edges of the two larger structures, almost like debris fields surrounding a much larger crash site. Then, in early 2026, a separate research team added another layer to the mystery entirely. Using a newly expanded global catalog of seismic wave data, scientists mapped deformation happening throughout the deepest reaches of Earth's mantle, and found that most of it traces back to something almost mundane by comparison, and yet strangely poetic long-dead tectonic plates, slabs of ancient oceanic crust subducted into the Earth's interior over hundreds of millions of years as tectonic plates collided, and one slid beneath another. Don't simply vanish once they disappear beneath the surface. According to this new mapping, they continue sinking, deforming, and dragging through the lower mantle for hundreds of millions of years, afterward warping the rock around them as they go, all the way down to the core mantle boundary itself. Earth's interior, it turns out, still actively remembering and reshaping itself around plate tectonic events that occurred before most of the animal life we'd recognize today had even